39 told us that we have a first derivative graph and wanted to know how many points of inflection. And we said that we know a graph first derivative is increasing, the original is concave up. So we look at how many times it changes from increasing to decreasing, and that was 4 times. We're now on page 40, number 5. Do you need that one? That was finding a minimum with a polynomial function. Are you good there? Okay. So we're going to go on to page 41, number 7. What about that? Okay. See, I put another one on. I must say, I had to cut out 6 problems because we hadn't gotten there. This is one of the ones I've added. You missed the first one, Miguel. I'm glad we're doing another one. We have h approaches 0. We've got, look how good it's working now. Maybe I shouldn't have said that. Thank you. So we've got absolute value of x plus h minus the absolute value of x all over h. And they want this limit at x equal 3. So who can tell Miguel what this question is asking? We just did one of these. What is this question asking? What is this limit as we have x plus h's and h goes to 0? What is this? Definition of derivative. So this is saying, what is the derivative? And I just asked you to identify the function and point. What is the derivative of blank at x equal 3? So the blank is your function. What is your function? It is not just x, but the absolute value of x. You see, every place you see x plus h, we replace with what? X. So before we can find that derivative, what do we have to do? In order to find the derivative, and I did teach you had a worksheet on this. Not very many problems, but you did have one. We have to change this into a what? Piecewise, where we have the function as it appears and the opposite. We're going to take whatever's inside, we're going to set it equal to 0. So that means my restrictions are going to be at 0. Now you have to ask yourself, which side of 0, the left side or the right side, keeps x positive? The right side. Which one of these, which side of this, let's see, which side of 0 keeps this positive? The left or the negative, because these will be negative, negative, negative is positive. Now the question is, where is 3? Is 3 on the top function, or is 3 the bottom function? It is the top function. How do we know 3 involves a top function? It is greater than 0. Do you remember how to do the derivative of a piecewise function? What's the derivative of the top function? What's the derivative of the bottom function? So when you have numbers that are bigger than 0, the derivative is 1. And when you have numbers less than 0, oh, we can put an equal sign anywhere. Then the derivative will be negative 1. And actually, why am I not going to put a bar here? What's happening at 0? No? So it's absolute value. What's the shape of an absolute value? It is a V. Sharp turns happen in there. So what's this answer? What's the derivative of f at x equal 3? Now wait a minute, it's at x equal 3. 3 is bigger than 0, so what is it? 1. All right, did you need help on 8? I'm thinking yes. Do you want to see 8 or not? Okay. So we have a function y equals x to the 4th plus bx squared plus 8x plus 1. And they're telling us that there's a horizontal tangent. Let's stop right here. What does that mean if you have a horizontal tangent? Miguel, what does it mean to have a horizontal tangent? Okay, do you agree this is a horizontal tangent? Yes? Okay, what do we know about that line? What's special about that line? At one point, okay, the y values will be equal here. That's true. What else can you tell me? The derivative of this curve is going to equal the what of this? Slope. Do you know what that slope is? Yeah, you do. It's a horizontal line. The slope of the tangent line is what? 0. Write this down. Highlight it. This is the big idea behind critical numbers. All right, so that's one thing we know. And it says it has a point of inflection for the same value of x. So what this is saying is this point right here, that point, is a point of inflection. What derivative involves slope of a tangent line? Which first derivative? What involves a point of inflection? Second derivative. So with this information, this is how we dissect the problem. What do you think we're going to have to do to these problems? The first derivative and then the... So this is going to be 4x cubed plus 2bx plus 8. Now, before I go any further, what does this tell me I'm going to do with this first derivative? Set it equal to 0. So we got 4x cubed plus 2bx plus 8 equals 0. Now, can I solve that with a b and an x? Absolutely not. All right, so now where are we going? Second derivative. So we're going to have 12. Now, what told us that we had to go to a second derivative? The fact that we had a point of inflection. So can we solve for, now, how do we find points of inflection once we have a second derivative? Where do those occur? We set this equal to 0 also. So now, can we solve for b? How do we do that? How do you solve for b? So, Morgan, how do we solve for b? Okay. And we're going to get, and yes, that it's still x squared. But what can we do with this? What can we do? Substitute it where? Oh my, will I have an equation in one variable? Yes. So now this equation is going to become 4x cubed plus 2 times negative 6x squared. That's the b part. And then there's another x plus 8 equals 0. So I have 4x cubed minus 12x cubed plus 8 equals 0. So we have negative 8x cubed plus 8 equals 0. Heather, how do we solve? So we have negative 8x cubed equals negative 8, then what? So x cubed equals 1. Now what? X equals 1. Now, they want to know the value of b. Where am I going to find that value of b? How do I get it? We're going to substitute our 1, aren't we? So that's going to be negative 6 times 1 squared, or what? Negative 6. Yes. Because if you plug it back into the second derivative, you're going to get 0 equals 0. Whenever you solve for one variable, it's always got to go back into a different equation. That's the substitution method, is what we just did. So we were on page 40. Now we're going to go, actually we were on page 41. Yes, now we're going to go to page 44, number 13. Did you, oh my goodness, what did we have again? Do you need this one? It's implicit again. Do you need it? You want to see it? Okay. So if you're taking the optional, this is probably more the speed I did for your optional. So problem 13 said if x plus y equals xy. Now, where is a big mistake going to occur if you're going to make one? Left side or right side? The right side. What are you going to miss? Exactly. This is product rule. So we're going to say the derivative of x is 1, and do you remember how we did dx over dx? Plus the derivative of y is 1, and that's going to be dy over dx, is equal to, all right? What do we do? JP, what do we do? How? Okay, so what you just did is you said the derivative of y was 1, and I just did the derivative of y with respect to x. Then what? Over. All right. So this is going to become 1 plus dy over dx is equal to x dy over dx plus y. Maddie, what's next? Okay, so let's look at our answers. Let's see. A has x minus 1, B has x minus 1, C has x minus 1, dx is positive. The only one where x is negative is in E. So should I move the x to the left, or should I move the dy over dx to the right? Maddie, what do you suggest? If most of our x... Yes. Do you see how I made my answers, multiple choice answers, work for me? All right, so we've got 1 is equal to x dy over dx minus dy over dx plus y. All right, what's my next step going to be, Riley? No, I need these, all these on the same side. So who has to move? Yes, how are we going to do that? Correct. All right, so now we're going to end up with x dy over dx minus dy over dx. What are we going to do next? Sophia? The goal is to get this by itself, and it's in two terms. What do? We are going to factor out a dy over dx. Now be careful. What do I get here? Minus 1. All right. And what's my last step, Emil? So we're going to have 1 minus y divided by x minus 1. Is that one of our choices? And it is C. All right, that was 44. Number 13. Now let's go to page 49, number 23. Do you need 23? What kind of problem is this? I'm thinking you have a related rate question on your test. All right, the edge of a cube is increasing at a rate of 500 centimeters per second. In terms of the edge of the cube. What does that mean? Those words about your answer. Are you going to have a number? No. We're going to have a variable. What is the rate of change in volume? So what's the volume formula for a cube? S cubed. And why did you choose S and not X, Caleb? Oh, I didn't see that. I was looking at the multiple choice answers and saying, oh, they got S's, so I have to use a variable S. All right, so he did a better job reading than I did. Good job, Caleb. All right, we're going to ask Gabby, you can do the derivative with respect to time. Okay. So they said that the edge of the cube, which would be ds over dt, is changing at a rate of 0.05 centimeters per second. Now, how do we get the rate of change in volume from here? Ashrita? Oh, I used x. Ashrita, what do I do from here? So we got 3s squared times 0.05. And when you multiply that, what do you get, Catherine? What's 3 times 5? And 2 decimal places. Okay, and this is something that you have to do without a calculator. Okay, this is something you have to do without a calculator. So the answer is D. So from 49 we go to 52. Were there any questions on 52? It was problem 1. 29. Now notice, we are in the graphing calculator section of the test, and do we need a graphing calculator for 29? Yeah. So let's just look at what they gave us. If f is a function, this is 29, it says the limit of f of x minus f of a all over x minus a as x approaches a is equal to 0. First of all, before we go any further, what is this? Okay, so this is the derivative, D-E-R, that's a big R, derivative of function f, correct? At what? X equal a. Okay. Now, they're saying that the derivative equals 0. What does that mean this is going to be? When is the derivative, what do we get when we set the derivative equal to 0? Okay, how about let's just go with critical numbers. And these critical numbers could be what, Caleb? Could be a maximum, it could be a minimum, or neither, right? So they're saying in part A, they're saying that the limit as x approaches a of the function does not exist. Now, for the limit of the function not to exist, now is that a derivative? How do we know that's not a derivative? The derivative is the limit of the algebra 1 slope, correct? Do you see algebra 1 slope with f of x? Okay, when a limit does not exist, what do we know about the function? What makes limits not exist? not continuous, means f of x is not continuous. Does the derivative exist at a if it equals 0? Yes. So is it possible for it not to be continuous? No. So we know a is wrong. So now they're saying f of a does not exist. If there is no y value, how in the world could you do this limit and get 0 without a y value at a? Is that possible? No. So B is bad. What they're saying here is they're saying f prime of a is equal to 0. What is this saying? What does this mean? What is that? Isn't that what this is saying? The derivative of function f at a equals what? Is that true? Is that not what we said this was representing? That is true. All right, I still want to go and look at the other ones because you might encounter these later on. They're telling us that the y value has to be 0. Here we're saying that the derivative is 0, and now they're saying the y value has to be 0 also. True? Is that sometimes, always, or never? It's a sometimes, which means it can't be true. F is continuous at x equals 0. F continuous at x equals 0. Where is f continuous? For sure. But the only thing we're guaranteed that f is continuous at a, because a derivative exists. Did they tell us that a was 0? No, they did not. So can we say anything about that one? No. All right, so that was page 52. 31. Let f be a differentiable function, a function that is differentiable everywhere. What does that mean, differentiable everywhere? What does that mean? It is continuous. So this is question 31. F is differentiable. When you see that word, I want you to immediately think what? Continuous. Also, what else do you know if it's differentiable? Know what? Sharp turns. Because sharp turns are the only way it could be continuous and not differentiable. The value of the derivative is given for selected values in the table below. Now it says f prime of x is always increasing. What does that mean? What does this mean? F prime of x is always greater than 0 or positive. So now which statement must be true? Is it possible to have a minimum if you're always increasing? Oh, wait a minute. The derivative is always increasing. That means the derivative, no. The derivative is always increasing. That means f of x is always concave up. Always concave up. There are no sharp turns. It is differentiable. Now, is it possible that I could have it? Let's look at some pictures. Is this derivative always increasing? But is it possible that the original function could be decreasing and increasing? Okay. So they're saying for number 1 that there's a relative minimum at x equal 0. True or false? Is that an absolute have to be? It could be true. What leads you to think that it might be true? Okay, so maybe your first clue then, you saw at 0, the derivative was 0. And what did you see over here? This is f prime. So if we know f prime of x is negative, what is it doing here? It's decreasing at this moment, and what's happening here? It's increasing. And if it's always concave up, is this a critical number? So if it's always concave up, does it have to be a minimum? Yes. So now they're saying it's concave down. Is that a direct contradiction for the fact that the first derivative is increasing? This is what they're testing right here. Do you, and this is the way they test these little pieces. Do you understand that this means concave up? So that's what they were testing, that there's a point of inflection. Now, just because we're at -5 here, and we're at +5 here, does that mean that this is going to be a point of inflection? Can it be a point of inflection? If you're always concave up, is there going to be a point of inflection? No. F of x passes through the origin. How is that an easy thing to say yes to? When not necessarily. It could be a sometimes. What would make you pick that? You see 0, 0 here, don't you? But what is that? It's a slope. It's not a y value. So that, a lot of kids will pick D. And F is odd. Now, that certainly looks odd. However, odd functions take the x's, turn them opposite, take the y's, turn them opposite. Does that look odd? That does look odd. But just because these are opposites, does that mean that one will be, and -1 will have opposite y values? Absolutely not. So that was why 31 was the way it was. All right, that was page 53. Page 54. Do you need to see 33? Okay. These were thinker questions, weren't they? We like thinker questions. Because you are that good. So here's our picture. This is an original function. That's one of the first things you want to notice. And I don't think it matters where this is happening, but notice this is doing this. Oh my goodness, it passed through a horizontal asymptote. Is it allowed to do that? And then, and I don't know if my concavity is important, but we'll see in a minute. The figure above shows the graph of a function f of x, which has horizontal asymptotes of 3 and -3. So let's make sure we put 3 and we put -3. So which of the following statements are true? So the first one says that f prime of x is less than 0. And that is on the x is greater than 0. So what that means is I'm not to look at which side of this graph. So looking at this, is this a true statement? This is the original graph. What does the first derivative less than 0 mean? Decreasing. Is it indeed decreasing? Okay, we know it's not going to increase because it's going to approach that asymptote. All right, so I would say that that one is true. Then they're telling us that the limit of f prime of x as x approaches 0, no, infinity, is 0. Have you ever seen the limit of a derivative? What is a limit? Tell us. Thank you. What are the y values approaching? So if I want the limit of the first derivative, I'm asking, what are the y values approaching in the first derivative as x goes to the right forever? when you see an original graph, where do I see, or how can I see the first derivative? The first derivative is the what? Sarah, what's a derivative? Correct. So if I want to see what's going on, I've got to look at these slopes. And as we get farther and farther to positive infinity, what can you tell me the limit of my slopes are going to become? This is horizontal. It's getting closer and closer, which means the slopes are going to get closer and closer to what? 0. Is that true? Yes. This one was true. What's the third one? Now they're saying that the limit of f prime of x as x approaches negative infinity is 3. All right. Again, pay attention to your notation. What are they asking again? They're asking for the what? The derivative. So as we go to the, and this is not quite as obvious, let me draw a better picture here. This is going to be doing this. As we get closer and closer to negative infinity, what are these slopes going to do? Where are they going to approach? 0. Is this true or false? Okay. Why do a lot of kids say that's true? They are ignoring the fact that that's f prime of x, and they're looking at it as if maybe it were a first derivative graph, or they're treating it as f of x, the derivative in this part. So the only two that were true are a and b, which would be d. All right, that was page 54. Ooh, we're going to jump to 72 now. Page 72. Oh, here's a free response. My goodness, it does look like something that you had. All right, 72. We're only going to do A through C. It says the figure above shows the graph of the derivative. Most important thing, you see a graph, find out what it is. Original, first derivative, second derivative. Now, the domain does not go past -4 or 4. The derivative of f is even, and they're telling you that at -3 and 3, the derivative is 0. The derivative at -3 is 0. So that -2 is not the max or min, because if the derivative if f prime of -3 equals 0, then that means that's the slope of the tangent line at -3. So that diagram's a bit deceiving. For what values of x in the interval -4 to 4 is there going to be a relative maximum? How do you do this? I think this should have been relatively easy for you all. Am I right or am I wrong? You're looking at a derivative graph. So, if I wanted to do an increasing, decreasing table, what would be my intervals? Jesse, what are my intervals if I want to do increasing, decreasing graph for for the graph? Oh, that's the -3. The -3 equals 0 means it's on the x-axis. Keep going. -3. Okay, so we are going where the derivative equals 0. So the derivative is 0 at -3. When's the next time it's going to be 0? And then we're going to do 3, 2, 4. So now we're not going to do test values. What we're going to do is we're going to look at the graph. So what can you tell me about f prime? Actually, we are going to do test values. Give me test values, because we've got to be able to look. What's a good test value between -4 and -3? So for Shivani? Here? Here? All right. So the question is, At negative 3.5, Emil, is the derivative positive or negative? Negative. What about at 0? Is it positive or negative? Because it's above. At 3.5, positive or negative? Negative because it's below. So they want a relative maximum. So F is decreasing, then increasing, then decreasing. Where's our relative maximum? Riley?
Our relative maximum is at
All right, what did they say? Oh, you have to do that. So you would say at x equal 3, y.
f prime of x is equal to 0.
Okay, and we're going to put in the 3 there. And
As f prime of x.
there you go. All right, so now this is increasing, decreasing, and it's f. So we want to look at this line. Changes from positive to negative. Is there another way we could have said it? I'd accept 2 answers. Changes signs, either one. This is definitely more specific. All right. So you probably get a point, I'm guessing. You probably get a point for identifying 3 and probably 2 points for the justification. For what value of x in the interval from negative 4 to 4 is there a relative minimum? What would that answer be, Miguel? At x equal negative 3, and what would be your justification? Changes signs. All right. It might be 2 and 2. I bet it's 2. I bet it's 1 for the x, 1 for the reason, 1 for the x, 1 for the reason. C, for what values of x is the graph concave down? Use the first derivative to justify your answer. All right. So when are we concave down? Ashrita? Okay, but give me the intervals. Uh-huh. 3 to 4? 2 to 4. And that is because the first derivative is decreasing. They didn't ask you to justify with the second derivative, did they? So you have to be versatile here. All right, and you can't do the next one because you don't know what that is. That wasn't a bad one, was it? Page 80, number 12. Did you need help on 12? Oh my gosh. That's not the asymptotes we did, was it? On the last test. First glance, I thought it was the asymptote. All right. This is number 12. What we've got is we've got the equation of a line tangent. Now, the equation they already gave us equals x plus 4. And it's tangent to the curve y equals kx plus 8 over something, k plus x. So, they want to know the value of k. If we have the equation of a line tangent to that curve, what do we know about the y values? What do we know about the y values? We've got a curve, we've got a tangent line. What do you know about the y values? They're the same. And what do we know about the derivatives? The derivative of this line and the derivative at that point. They're equal because the slope of the tangent line is equal to the derivative at the point of tangency. So what we're going to do is we're going to pause and come back to this after break. All right, so this is what's going to drive our problem. We're going to say that x plus 4 is equal to kx plus 8. Just kidding. All right, can we solve this equation right now? Can we solve this? No, there's two variables. All right, so now what are we going to do? The derivatives have to be equal. By the way, what's the derivative of this? 1. So we're going to say 1 equals, but what do we have to do to get the derivative of the other? What do we have to do? Quotient rule. So we are going to say the denominator times the derivative of the numerator, which is what? K, minus the numerator, and what's the derivative of the denominator? 1, because k is a number. So, and then we're going to have all over our denominator squared. So we're going to have 1 equals, this is going to be k squared plus kx, distribute minus kx minus 8. Oh, what happened? We've got k plus x quantity squared. What happened in the middle? They canceled. So now I'm going to have 1 is equal to, oh, what didn't I bother to look at? Oh, I still have to finish this. What did we say? Where did we get the 1? Oh, we might not need this. Okay, so we've got k squared minus 8 all over k plus x quantity squared. Now, there's my derivative. They're saying that the equation of the line tangent to the curve y at x equal 2. So at x equal 2 is when this is happening. So what can I do now? X equals 2. What can I do? Plug it in. 1 is equal to k squared minus 8 all over k minus 2 quantity what? Squared. Am I making this more difficult than it needs to be? I don't think so. All right. So we're going to say k squared, k minus 2 quantity squared is equal to k squared minus 8. And what are we going to do? Yeah? It was negative 2, but that's k plus x. So I put it in, and it may have made it minus. Am I good? Did I make a mistake? Okay. So I'm going to write this out twice, because what happens when I don't? We miss the what? Middle term. So we get k squared minus 2k minus 2k plus 4. What happens to the k squareds? They cancel. So I guess, sorry, I haven't added them. So now when I add negative k squared to both sides, they're gone. I'm going to add negative 4, and we're going to get negative 4k equals negative 12. What does k equal? 3. And hopefully the answer was D. What was the answer? Sweet. Okay. This is what they call a parameter problem. And bottom line, what were they checking? They were checking to see if you understood that the derivative is the slope of the tangent line. That's basically the concept that they were working on. All right, so that was page 80. Let's go to 85. Did you need 85? Yes. Oh, maybe. What did you do?
I said, this is y equals k plus 8, plus x plus y equals x plus 4. So I set those two equal to each other, plugged in x equals negative 2.
So what you're saying is I could have put the negative 2 in right there and would have gotten it easier. negative 2 plus 4 equals negative 2k plus 8 over negative 2 plus k. Oh my. So this is going to be 2 is equal to negative 2k plus 8 over k minus 2, and we're going to turn that into a proportion, and we're going to get 2k, I distributed as I multiplied, is equal to negative 2k plus 8. I'm going to add 2k to get 4k. I'm going to add 4 to get 12, and I got k to be 3. Thank you, Caleb. I made that a whole lot harder than it needed to be. So there are two ways to do this problem. What do we say? We can work smart, which Caleb did, or we can work hard, which is what I did. All right, 85, number 21. Do you need it? You're looking for a point of inflection. So I think we want, again, they love equations of tangent lines. Did you notice this? Equation of line tangent. What do you need? We need two things to write the equation of a line. Slope of the tangent line, which is the derivative, and a point. We have a curve. That's the good news. The question is, do we have the slope? Do we have slope? Riley, have we been given slope?
No, you're not.
Okay. Have we been given our point? Okay. But did they tell us what point it's happening at? What do you think you're going to have to do first? You're going to have to find your... Let's do this. Let's do first derivative. When I do the first derivative, what is that going to be, Morgan? Okay. Now, in order to get the slope, don't I need an x value? Do I have an x value? Emil, do I have an x value? So what do you suggest I do if I don't have an x value and this is happening at the point of inflection? But but that's saying that the slope is 0 when we set it equal to 0. So all this is happening at the point of inflection. It's this, that's going to be my point. All right, that's going to be my point. That will be the x that I substitute here. So how do I go for a point of inflection? I'm going to need a second derivative. So we're going to have 6x minus 12. Now, Emil, where will this point of inflection occur? When the second derivative equals 0. So we're going to say 0 equals 6x minus 12. Solve my equation, Heather. And that's going to be, so I have half a point. Can I now find slope? There's my slope generating equation. Do I know my x? Yes, no. So my slope of the tangent line is going to be 3 times 2 squared minus 12 times 2, or 4 times 3, which is 12, minus 24, what? Negative 12. So there's the slope of my tangent line. What's the only thing I'm missing? JP? How do I find the y value? Look at that. We've used a slope generating function. We've used the second derivative, and now we're going to use the original. So my y value will be 2 cubed minus 6 times 2 squared, which is 8 minus 24, which I think is negative 16. So my ordered pair is 2, negative 16. Can you write the equation of your line now? Sarah, go ahead and write the equation of our line. Okay, equals times. Okay, and I stop here and I look at my multiple choice answers and I don't see it. But what I do see on my multiple choice answers is they're all y equals. So what do we have to do? Solve for y. Distribute, you get negative 12x. You get positive 24. And to move 16 over, I subtract. So y is going to be negative 12x plus 8. Is that an answer? Please tell me that's an answer. Okay, so that worked. All right, what's our next question? Okay. Logan, would you put these in order? I borrowed these and I don't want to give them back out of order. And so they're all out of order. Okay. So this was page 85. We're going to 108. I think that might be a free response. It is. Now, this would be a fair free response for y'all. So let's see what they've done. They said let f of x be a function defined by. This is 108, page 108, number 5. All right, so we have f of x is equal to. On your homework, would you please write the page number and then the problem? You're going to get a higher grade if you do that because I'll be able to find them all. Plus 3x squared minus 2x cubed, where k is a constant. They want to know on what interval is the function increasing. If I'm looking for increasing, what derivative is that, Catherine? So we're going to go for a first derivative, and what happens when you take the derivative of k? It's gone because they told us it's a number. So derivative is going to be 12 plus 6x minus 8x squared. All right, so we need increasing. What's my next step that I need to do, Gabby? All right, so that means I'm going to factor out yeah, Maddie? Oh, I said, wow, that's not even close. 2 times 3 was 8. What does that mean I can factor? That's 6. So that means that becomes 2, that becomes 1, this becomes minus x squared. I like it. Now, I'm only going to divide by 6 because there is no variable. The factors of 2 are just 2 and 1. What are the factors of the x? Just x and x. Now, I need a negative x and I need a positive 1 in the middle. So do you agree that my outside will be positive 2, my inside will be minus 1 to give me a positive x? This means x equals 2 and x equals negative 1. Where is this derivative undefined? Maddie? Never. All right. So they're asking for increasing. So what do you need to do? Table. And I've got 2 numbers to put into my table, which means I'm going to need 3 pieces. All right. So we're going to do negative infinity to negative 1, negative 1 to 2, and 2 to infinity. So test value, what do we have? Give me one. Aditi? And? All right, that's test value. So this is going to be the first derivative. So 2 minus a minus 2 is positive. 1 plus negative 2 is negative. Putting in 0, we get positive. 2 minus 3 is going to be negative. Therefore, my function is decreasing, increasing, and decreasing. I bet we're going to be able to do a lot of this problem now. So the first part said, on what interval? What interval is it increasing, Shivani? And you are to justify. Why? Correct. And you've got to justify using your derivative line. If the relative maximum value of f is 4, what do they mean by that, Caleb? The maximum value is 4.
Well, that means that means it's concave down if there's a maximum value.
Okay, but what's the difference between a maximum value and a maximum? What does that value mean? Anybody? It's the y value. So this means that your maximum point is going to be something 4. Does that make sense? When you see minimum value, that's the y value. Caleb, do you know the x value that that's happening at? Look at your chart.
Oh, yeah. That's definitely.
Right. How did Caleb get that? What is this right here? Maximum. And where's it happening? So we have this is a point on the graph. They want you to find k. Why is it futile to put it right here? Why is that a waste of our time? Exactly. So where do we have to substitute it in? The original. All right, and my original's in 2 pieces. I guess I can handle the first part. So here we go. We've got to put, where are we going to put the 4? In for what? Y. So we're going to say 4 is equal to k plus 12 times 2 plus 3 times 2 squared minus 2 times 2 cubed. 4 is equal to k plus 24 plus, that's going to be 4 times 3 is 12, minus 8. Oh, goodness. 12, 24, 34, 35, 36. Go back 8. Oh, I didn't see that. Yep. I wouldn't have gotten the right answer. Is this a free response? I would have lost a point. So we're going to have 36, take away 16, which is so much easier to do in our heads. What is that? 20? What is k? Negative 16. All right, they didn't ask us to justify. Now they want to know, where is the function concave up? What derivative's involved, Emil, for concave up? Yeah, but you know what we need? We need to find our first derivative. This is the only problem with a smart board. Oh, wow. Let me fix this. All right, so here's our first derivative. We'll just bring it on down. All right, what is that second derivative going to be, Emil? Good. What are we supposed to do? Concave up. All right, what's my next step, Sarah? All right. Riley, what is x? Negative 6 equals negative 12. X. Ah, very good division. A lot of people tell me that's 2. All right, now that I get this point, what am I supposed to do, Jesse? F double prime, undefined. Where? Never. Okay. Now what am I going to do, Sophia? I'm looking for concave down, up. Would you like this as a free response question? This would be a nice free response question. Negative infinity to 1/2, 1/2 to infinity. Test values, Shivani? All right. We are putting this into the second derivative. And this is the second derivative right there. So what do you get when you put 0 in, Heather? which is positive, and when you put 1 in? They want to know, where is the function concave up? Do we have enough information to answer this question, JP? Okay, where is it? Why? Because f double prime is greater than 0. All right. Now, the last part, notice they put that at D. They should have put that probably at B. Again, there's that keyword, and that keyword is minimum value. What are they looking for? The y value where? At x equal what? The y value at x equal 1, negative 1. How do we know? That's where the what happens? The minimum. So we're going to take, oh, what was k? K was what? Negative 16. So I'm going to put negative 16 here. So we couldn't have done it at B. We'd have had to do it after C. So we're going to have, I'm substituting in negative 1. Negative 16 minus 12 plus 3, and that's going to be minus 2. So that's negative 28, negative 25. How about negative 27? Did anybody get negative 27? Did I mess that up? Oh, that's plus 2, is what you're telling me? Okay, so now we've got negative 28 plus 5 is negative 23. Is that better? For sure? That would be part D, and they did not ask us to justify. All right, so is the free response less scary? Hopefully, maybe. We're going to go to 112. We're back to a new multiple choice, number 2. Do you need help on number 2? Number 2, yes or no? Yes. Okay, and why do I think you want number 2? Because there's trig in it, exactly. Page 112, this is number 2. All right, what are we doing? It says equation of tangent line. What do you need to write the equation of a tangent line, Gabby? What do you need to write the equation of a tangent line? What does it? The slope of the tangent line and the point. Thank you. All right. So they did, oh, look at this. What did they give us? They did half our work. Now, did we review trig at the beginning of the year? Yes. All right, what is this derivative? Caleb?
It'd be negative sine of x. Secant squared of 2x times 2.
What's the most forgotten part of that derivative? The 2. All right, what do you think you need to review? The trig derivatives. All right, so we have, what do we need to do? Okay, we have a point 0, 1. So we need negative sine of 0 plus secant squared of 2 times 0 times 2. Where is 0? Where is it? It is our positive x-axis. This is going to be 1, 0. I don't have this child. Oh, they can't do third period. They need to do another period because after the beginning of the year, all those kids get dispersed. Yeah, okay. So that they'll have to catch him another time. All right, so this is x, this is y, r is 1. What is sine? Ratio? X, y's, and r's? Y over r. What is the y? 0. Say no more. Okay, what's the ratio for secant? R over x. What is r? What is x? So therefore, if I have, so the secant of 0 is 1, and I square it and multiply by 2. All right, Catherine, you get to write the equation of the line. Yeah.
Are we using 1, 0 as the
Oh, because I have to put in the x value of my point. The x value goes into my trig function, into my equation to get the slope. Does that make sense? If this were implicit differentiation, I'd be putting x and y in. So that means the angle is 0. That's why I'm here. Okay? And when I draw my unit circle at 0 radian, that is a radius of 1 with, and I haven't gone up or down. Is that cleared up? Okay. Catherine, you're writing the equation of our line.
So it's y minus
Oh, wait a minute. I got a circle tool. All right. So y minus 1
equals 2x.
Okay. Is that an answer? No. But if you look at the multiple choice answers, it tells you what form it needs to be in. All of them are y equals. So there you go. And this was page 112. So we're the top. Now 113, do you need 3? We need to talk 3? Or were you good on 3? You're good? Okay. I hit that pretty hard, didn't I? 117? That's 118. 117, 12. What about 117, 12? JP's good. Is everybody else good? Caleb's good. Everybody else? Anybody want to see it? Okay. Then we are going to go to 118 and 118, number 13. Do we need to do that one? Did I prepare you for that one too? Yeah, I did. All right. So are you feeling pretty good about the AP exam now that I've prepared you? Truly, 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 I have tried my darndest. All right. Number 16 on page 119. Do you need this one? Okay, so the gentlemen are in agreement, but what about everybody else? Maddie? Okay. So what kind of problem is this? A related rate, and if you're taking the optional today, guess what's on your optional? A related rate. So this is page 119. This is going to be number 16. So what does it say? It says the volume of an expanding sphere is increasing. So what will my rate be? Positive. At a rate of 12 cubic feet per minute. So that's dV over dt is going to be 12 cubic feet per minute. Per seconds. Okay. When the volume of the sphere is 36 pi. Now they gave you that for a reason. That means they didn't give us something we needed. How fast in square feet is the surface area increasing? All right. So I need to know surface area formula they gave you to be 4 pi r squared. Ultimately, do we need to do this derivative? Derivative of surface area with respect to time is going to be what, Ashrita? D r over dt. So now it says We're to find how fast the surface area is increasing. This is what I want. And what don't I have? I don't know R, and I don't know dr over dt. So, someone suggest how I find R. They gave us the volume formula, which was 4 pi r, 4/3 pi r cubed. So that should equal 36 pi. What do I do with the pi? Divide? It's gone. I'm solving for r. What do I do next? Multiply by the reciprocal. How many times does 4 divide 36? 9 times 3. So what is the cube root of 27? 3. So now I know my 3, my r. What don't I know? So what haven't we used yet? What did they give us that we have not used? That's correct. So what do you think you're going to do now? You've got volume to be 4/3 pi r cubed. What are you going to have to do? Take the derivative with respect to time. So that's going to be 4 pi r squared what? dr over dt. They told us that the rate of change of volume is 12. We found the radius to be 3. Can you solve for dr over dt? I think that's going to be 3 times 3 is 9, times 4 is 36 pi. So now this is going to be 12 divided by 36 pi. What does that reduce to? Where's the pi, though? Okay, the pi's still in the denominator. Common mistakes to take it out of that denominator. Now I've got enough information for my dr over dt, which means we can now finish the problem. Rate of change in surface area with respect to time is going to be 24 pi times 1 over 3 pi. The pi's simplify. 3 divides 28. Oh, just kidding. 24, 8 times. So that's going to be 8. This is area, and I think it was feet. So I think that's going to be square feet per second. And what is it? Should be A. Yeah.
Oh wait, was this multiple choice?
Yes.
This was a free response, and it makes sense because of the final response.
No. You will not.
What about
I don't know. Do you want me to give you credit for it? That's 4 points. You know what I mean?
I mean, yeah, that's pretty easy.
Okay, then we'll do it. Just remind me. Ask me that question again this afternoon. Okay? So here we go. We are now doing page, what did I just finish? 19? Page 121, number 20. Do you need that one? I didn't look at it. Anybody? Okay. Then we're going to go to page 121, number 20. 124, number 26. Do you need that one? Oh, but we have to do this one. Didn't I? Oh, I did this one this morning. Yeah, we've got to do this one. This is page 124, number 20. You see the derivatives I had, and we couldn't do all the derivatives on that worksheet. And by the time we had that, we didn't know derivatives. All right, so we should be pros at this now, correct? Oh, this is page 124, number 26. Better? Please tell me it's still this problem. Okay. all over h as h approaches 0. That's very intimidating, if you ask me. But what do we know this is? What is this asking? What is it asking? It's not a y value. Let's help Miguel, because I don't think he was here. He only saw one of these. This is our third one. What is the derivative of f? They didn't give us a point this time. So the first thing you have to do, which I did ask you to do on a worksheet, what is the function? Every place where you see x plus h, what are you replacing it with? X. So what is your function? Tan what? 2x. So what is your derivative? Chain rule. What's the derivative of tan? Secant squared of the angle times the derivative of the angle, which is? So your answer should have been 2 secant squared 2x, which was D. Do you know what the most missed request, or most, the kids that miss this question, what the biggest response is? No, C, because they didn't do the derivative of the inside. All right. That was 124. We're now down to 134. What about 134? Number 134, 44. Don't we do that one? Shivani said no. Anybody say yes? JP said no. Anybody else? Okay. Then that is, so now we're going to go to 146, number 6. Oh, nice. That's another free response. Okay. So what have we been given? See, I tried to give you some free responses to look at. Page 146, number 6. Do we get to do all of it? I think so. The figure above shows the graph of the what? Derivative of a continuous function. The function itself is what? Continuous, even though the derivative is not. From 0 to 4. So the question is, where is the original function that we cannot see increasing? What would you tell me? 0 to 2 and 3 to 4. You have to justify because f derivative of x is greater than 0. B, for what values of f does it have a relative minimum? All right, so we need to get a table out. What's going to be my intervals across the top? 0 to what? 2, 2 to 3, and 3 to 4. If I choose test values 1, 2.5, 3.5, what's happening in my derivative function at 1? What can you tell me? Positive or negative? Positive. At 2.5? At 3.5? Don't you like to do the increasing, decreasing chart when you see the graph versus having to do all the algebra? Yes. I want it. Okay, so f is going to be increasing, decreasing, increasing. Remember, f is continuous. So we want a relative min. Where's the relative min? At x equal 3 because, justify, 2-part. F prime of 3, is it equal to 0? Yes, it is. And f prime of x changes signs. Don't talk about the bottom row. You got to talk about the middle row. All right, for what value of x does f have a relative maximum? What would that be? X equal to y. F prime of 2 is undefined. It's not 0, it's undefined. There's a break there. And f prime of x does what? F prime of x changes signs. All right. Now, if f of 1 is equal to 1, can you use the answers to sketch? Did you not just have a test on this? Yes? Oh, I need graph paper. Where is my graph paper? All right, so here's my graph paper. And what do we know? Maybe I can squeeze this in. So we're starting at 1, 1, correct? Or that point's there? 1, 1. Did our table start? All right. So they want us just to graph from 1 to 4, not starting at 0. So when I start here, I need to go to 2. How do I go to 2? Besides increasing, I have to be, wait a minute, is the first derivative increasing or decreasing from 1 to 2? It's decreasing, so I need to be increasing and what? Concave down. All right, now from 2 to 3, we know I'm supposed to be decreasing, but what should my concavity be? Concave up. See the sharp turn? That's what caused that break. Now from 3 to 4, I'm above the x-axis, which means I should be increasing, but what is my function doing? Well, the function's increasing, so I should be concave up. And that's not an arrow, that's a dot. And that's a sharp turn. Right. I like that one. 146. 150, number 4. This might be our last one. Do you need 150, number 4? Okay, that was straightforward, correct? What about number 5? All right, this is easier than one we did earlier. They want the derivative of f. How do I do the derivative of f? F of x, this is page 150, number 5. All right, f of x is a piecewise function. It's x squared plus 2. It's 2x plus 1. This is for x is less than or equal to 1. This is for x is greater than 1. I need a derivative first. How do we do the derivative of a piecewise function? I don't want anybody to even question how to do this. What do we do? Gabby? Okay, do the derivative. And the bottom? 2. So all you do. You do the derivative of the top. You do the derivative of the bottom. Now, it wants f prime of 1. Which do I use, the top function or the bottom one? How do you know it's the top? Equal to. So f prime of 1 is going to be 2 times 1 or 2. Was that a sweet one? When you see a piecewise function, do you automatically have a panic attack? When you see trig functions, do you automatically have panic attacks? Then I need to decondition you. I need to give you lots of piecewise functions and lots of trig functions. All right, so we're at 150. 160 was 25. 160 is 25. Do you need to see it? Did I hear a yes? Okay, so that's where I'm going to stop. I'm going to make that notation. And I think we've got time